So I think the 15 minutes that we have now is a perfect platform to begin to think these questions through while interrogating our panelists for the presentation today. And I could start off with just something real quick for each of the panelists. I'll direct the question to them, but then hopefully we can get a conversation going on addressing the points that were just raised. So, I mean, excellent set of presentations, all of them touching on the importance, you might even say imperative, to better integrate our thinking across disciplines, right? The cross-cutting point that really strikes me is this notion of thinking of systems, coupled human nature systems, social ecological systems. This is all language now being used by the NSF and other organizations. And we're clear about that. But the other cross-cutting theme is the challenge of dealing with the basic science and getting that data going and building your experiments while also trying to be civically engaged, the science policy interface. So my question for you three is, in the pie chart of your time, to continue doing excellent basic science, how much of your time is being dedicated to sort of science communication and the science policy interface? And I realize, you know, the more you do that, the less you have for the basic science. So the question for us to ponder is, what kind of support can you use to be able to do that kind of research translation, to be able to meet the mission of our campus to become more of an engaged university? What kind of help would you need?
Let me just offer one thought that's a little bit related to that. It has to do with the nature between basic and applied research. And I think there's a premise that the basic researchers feed their way into the applied researchers and then up into societal benefit. I don't think it actually works that way a lot of the time. I think you identify a societal goal, like arms control or something, and then that motivates fundamental science like seismology. So, I mean, I think it's a two-way street. So I don't think there's any harm to the basic sciences by identifying interdisciplinary themes, because they will necessitate basic scientists that you know has societal value because it feeds into a theme. So I don't think anyone should feel threatened by an interdisciplinary focus in that way. Now, as for how I run my group and so forth, the split of my time, I have to say I do feel rather stretched away from basic stuff, kind of a regret of moving on in my career. But I have people who work under me that keep that going, so that it's a partly. But yeah, there's a lot of basic science that goes on in our work at Scripps and in my work. So I don't see.
Good, that's encouraging.
It's all pretty nicely mixed.
And you guys chime in. Yeah. Maybe. Did you want to go first, or do you want to wait?
Well, sure.
Well, just let's give the panelists the prerogative to say a few words, and then we'll go to the audience.
Sure. I'll just chime in. I'll say I probably spend less time than I should communicating with the public about the results of my science, and that's just because of the many demands that we have on our time. So I think, in some ways, it's valuing those contributions would probably help the most, and encouraging me to make that leap.
I find myself spending more and more of my time communicating, and I think technology can really help us. Webinars and other vehicles where we can, I can sit in my office and talk to many, many people around the world. I also think interdisciplinary graduate training is a very important part of this, because training our students to be communicators is going to make it a lot easier for them to be both scientists and address policy and address communication. And so starting right maybe at the undergraduate level and moving on up, it's going to make it easier than, say, for my generation, where we were never taught to communicate as part of our PhD research.
So we had a question, yeah.
Yeah, I'd be interested in your comments. Well, first of all, I thought they were great presentations, and I really, really enjoyed hearing them. I'd be really interested in hearing your perception of uniqueness from 2 points of view. One is the thing that you talked about something that everybody is talking about, or that you're way ahead of the curve on? And then uniqueness from the point of view of UCSD. Are we uniquely able to address this compared to other institutions?
Maybe go down one at a time.
Yeah, with respect to the emissions question assessment, there's a lot going on in different communities, but we are uniquely positioned here at UCSD in several important respects. First of all, we're the one state that has a cap and trade system in place, so we have a kind of a responsibility to our state to improve this technology. There's interaction with the California Air Resources Board on the same question of how to do this better. So yeah, there's special role for us in California to play a leading contribution. I should say also that the expertise in greenhouse gas measurements and aerosols runs very deep here at UCSD. And the links to the numerical side of the problem are I think what still needs to be developed, but we have all the building blocks here, and probably if we build from that, we'll be in really top of this problem. And as I said, we have a great opportunity to use this expertise locally.
So I think that there's a lot of interest globally in the responses of both species and ecosystems to environmental change. I think this is something that there are lots of people working on fruitfully here at UCSD. I would say that we probably have, yeah.
Can everybody hear okay in the back? You might
No.
have to speak up just a little bit.
Okay, I'll try to speak up more. Sorry, I have a cold. I'm a little quiet today. But I think that there's an area in which I think we need to work a little bit, and that is on the ecosystem side. So we're relatively limited here at UCSD in our expertise in some of these areas like soil biogeochemistry and ecohydrology, and climate modeling even. We sort of have one or two people we can point to, but their time is spread very, very thin. So I think we do need to leverage our strength that we have in understanding biological systems, but also I do think we need to fill some of those disciplinary gaps in order to make progress on these important issues.
Okay. As far as the deep sea, we have a lot of scientific expertise based at Scripps. We have wonderful economics expertise in the econ department, and they're growing more and more interested in this problem. We have people at IRPS and the Rady Business School interested in this problem, so I think but I would love to get the theater and dance department and the art departments and some of the other departments interested in this problem, because film and so on, because there's a wealth of opportunity out there in terms of the deep sea.
Other questions?
If you could name one or two or even three things that you think the university could do that would help you advance your goals in a quantum way, not just to take the next baby step, but really in a large-scale way to scale up some of these efforts. Could you just describe what some of those things might be? What types of things might help?
Well, a giant $50 million endowment would be a great start.
Okay, besides money.
You're talking about institutional support. I think that encouraging us to work across disciplines and taking away some of the barriers that exist to do that right now would help. And that involves things like teaching credits and degree programs and where your degree is from. And, there's a whole host of, a lot of siloing that goes on. And removing those barriers in a way that provides incentive to faculty, incentive to students, and makes it easy rather than difficult to work holistically, I think would be a great start.
My perfect dream wish would be an Institute of the Environment that brings together all of these different disciplines from across campus and provides exactly, teaching credit, an integrated undergraduate and graduate program. That would be the dream. That would be what I would love to see come out of this process.
I endorse both those. I'd like to suggest one other thing that I think could be strengthened here, and that's somehow the institutional support for postdocs. And in some ways, the real engine of pushing forward nuts and bolts on some of these problems requires depth of activity at that level. And I feel like that needs to be recognized at a higher level. And and particularly postdocs that are somehow spread between like engineering and other program scripts and chemistry, and somehow to make that more seamless. That would help.
Okay, there was a question in the back.
I had a couple of questions for Ralph Keeling. First, you described your dream as doing an inverse problem on atmospheric measurements, which sounds kind of hard. What have you thought about instrumenting the sources of emission themselves? You know, and what the feasibility of that is. And then second, I was just curious to know why you went with a commercial solution for this EarthNet, Earth observing system, as opposed to, a national consortium or a research and academic-based approach.
So the first question first on why not instrument the sources. Well, that can and should be the right approach for looking at things like stack emissions, where you have a concentrated source. But a lot of the sources of greenhouse gases aren't known ahead of time, or they may be dispersed. They may be related to agricultural practices. How do you instrument emissions of nitrous oxide from agricultural practice? You're going to put a sensor in every square meter? Of course not. So you have to disperse them around and then somehow make an inference from the atmospheric motion. So, yeah, it's application dependent, but there are many applications where you want to see at a larger scale what the emissions are, and the efficient way to do that and get it right is with an atmospheric inverse approach.
Right, but when it comes to measurement, there's always a near field, far field, aspect to it, and people walk around with cell phones. There's millions of cell phones. Could those be your instruments to gather, sort of the near field in situ data?
Well, most of the species we're thinking about, which we need to control, are not so easily measured as that. There may be a few exceptions. So, for example, let me segue to your second question. In the case of the Earth Network's deployment, they're putting basically $50,000 boxes out there plus additional hardware just to measure carbon dioxide and methane well enough to do this. That's not ready to be miniaturized and attached to a cell phone, not even close. I would bet it would actually never get there, but it may get better. As to the history of that particular program, Earth Networks approached us with an interest in this, thinking that they were going to take an early lead in kind of environmental information process, and greenhouse gases might be the interesting entry point into that. So it's not by any means the only thing we are doing and that's happening nationally or at our institution or elsewhere. It's just it was an interesting example that I pointed to, not because it was representing the main thrust overall.
Thank you.
Panelists for the presentation today, and I could start off with just something real quick for each of the panelists. I'll direct the question to them, but then hopefully we can get a conversation going on addressing the points that were just raised. So, I mean, excellent set of. So I think the 15 minutes that we have now is a perfect platform to begin to think these questions through while interrogating our systems, coupled human nature systems, social ecological systems. This is all language now being used by the NSF and other organizations. And we're clear about that. But the other cross-cutting theme is the challenge of dealing with the basics presentations, all of them touching on the importance, you might even say imperative, to better integrate our thinking across disciplines, right? The cross-cutting point that really strikes me is this notion of thinking of science and getting that data going and building your experiments while also trying to be civically engaged, the science policy interface. So my question for you three is, in the pie chart of your time,